Hello everyone, I'm Sam. Today, I'm going to introduce the XMC3W wideband ODU. The XMC3W ODU is the first wideband ODU launched by Huawei. An ODU can cover multiple TR spacings and frequency subbands. This makes TR spacings and frequency subbands remotely adjustable. Three highlights of the wideband ODU are as follows. First, wideband ODU can be used when frequencies are not determined in the initial stage of a project. This simplifies network design and supports fast deployment. Second, the BOM number of wideband ODUs is significantly decreased to reduce the number of spare parts, helping customers reduce OPEX. Third, the wideband ODU supports 4096 QAM modulation and can transmit large bandwidth services. The component that determines TR spacing and frequency subband information within the ODU is called a duplexer and consists of two filters. The central frequency of a filter of the traditional ODU duplexer is fixed. The wideband ODU adopts the innovative frequency broadband adjustment technology to adjust the central frequency of a filter through the micro CPU. This makes ODU TR spacing and frequency subbands adjustable through software. Now, I'm going to talk about how the wideband ODU simplifies network design and achieves fast deployment. In the following figure, the frequency planned in the early stage of a certain project was 7 GHz. In the actual delivery, perhaps because of interference or for other reasons, the planned frequency was changed to 7 GHz in different subbands or TR spacing. When replacing a common ODU, a new ODU must be delivered and be reshipped to the site. If a wideband ODU is used, change the frequency on the NMS instead of shipping a new ODU to the site again, thereby shortening the project period. The BOM number of wideband ODUs is significantly reduced. Take an ODU whose frequency is 8 GHz as an example. A traditional ODU needs 8 BOM types, but a wideband ODU needs only 2 BOM types. A decrease in the number of ODU spare parts not only reduces storage and management costs, but also decreases the operation probability for operation and maintenance engineers. For common ODUs, different subbands correspond to different ODUs. If the frequency subband of an ODU is changed during equipment migration, a new ODU is required. For wideband ODUs, one ODU supports different frequency subbands. A live network ODU can be reused even if its frequency subband is changed during equipment migration. This saves equipment costs for customers. XMC3W ODUs can interconnect with XMC3 or XMC2 ODUs over the air interface. However, there are some restrictions. The IDU version must be version V100, R00, 9C00 or later, and the IF working mode must be IS3 or IS6. In addition, wideband ODUs cannot be used with XMC2 ODU when XPIC applies. More details about the restrictions are listed in the table. 6 frequency bands are planned for wideband ODUs. The 7 and 8 GHz frequency bands have entered the GA phase. The 15 and 23 GHz frequency bands will enter the GA phase in the second quarter of 2017. The 13 and 18 GHz frequency bands will enter the GA phase in the third quarter of 2017. The insertion loss of an adjustable duplexer is greater than that of a common duplexer. Therefore, the wideband ODU system gain is about 2 dB lower than that of the XMC3 ODU. That's all for today. Thank you.